Well, hi, good morning. Welcome to my shop. Today is January 25th, 2024. Oh my gosh. And I'm going to test this radio. Having determined the mystery wire, having been very careful about that, because I did not want to make a mistake and endanger an IF transformer or something like that. I concluded it should be grounded. The wire has been soldered into a ground point here. Has it really? Yeah, that's okay. Okay. Well, so what I want to do is find out if making this change has somehow corrected what appears to me to be a weak AVC. The AVC voltage tends to hang around a volt, a little below a volt. And no matter what you're doing in terms of tuning, it just seems to wiggle a little bit. I doubt very much what I did is going to fix that. I don't really know what is causing that. In the meantime, I've put the original 6 or 7 C6 tube back into the radio. So it's back with its original tubes now. We're going to find out how well it works. And whether the AVC should... So that's 10 volts negative. The meter's set to negative. So an upscale or swing is actually a negative voltage relative to the chassis. Okay, I have the antenna switched on. Great forethought. Okay, we're going to go full voltage here. Okay, tuning around. You can see the AVC voltage. 3 volt scale, 1 volt is hanging just below. It's hanging around 3/4 of a volt. Oh my gosh. Where'd the volume go? Where'd the stations go? Where'd everything go? Okay, it's possible that this wire is affecting the operation of the radio, although previous testing said no, but let's just make sure. That was dropping the volume a lot.
Can't back pitch that top. For one, they did like that. That's an embarrassing play. A 2-0 short-handed, that never happens. And why did it happen? It's because they stayed out too long because they want to get the power play back on track, or they want to get their points or whatever. And then both the guys go off when the other team has possession.
So making that connection has dropped the volume a lot.
And it's one thing to stay up and take the whole 2 minutes when you're hungry.
I kind of wonder about the value of this.
And it's like, oh my gosh, this power play is going to score. Like when you just feel it in the belt. So they exhaust themselves.
That's full volume there. Well, I'm going to go and drink some coffee and think about that, because that's not a very good result. Now, the radio is generally used, I think, with the auxiliary input, and the weakness is coming from the radio circuits. It's not the amplifier. The amplifier is still just as strong as it was. So, I don't know. Should I disconnect that wire again and leave it off? Just to get the higher audio, or what is going on with no AVC variation or voltage? I don't know. I'm gonna go drink coffee and think about that. Okay, a little bit of coffee and just taking a break is very helpful. It gives you time to think about different possibilities. So what's happened here is I've connected this ground, and the output volume of the radio has gone way down. Why is that? So I might think, well, maybe this capacitor or this capacitor, maybe they're leaky bad, and maybe they're pulling down the signal. That's quite possible. Another possibility is, having connected this, the tuning of this transformer has gone off. Now, I don't know that that's the case. I mean, it's outside of the tuned circuit. It's down here. But it does go to ground through a capacitor. So perhaps the IF tuning has gone off, and that's why the radio is getting a little bit quiet. Another possibility in thinking about the AVC is that the IF was never actually tuned properly. It's tuned in a way which made the radio work when this was disconnected, with the extra signal strength that allowed, but once you connect this back and knock the signal down a little bit, you know what, that really shouldn't happen, should it? If everything were perfect, hooking this up shouldn't make it go quieter. So I would really go back to the detuning of this. I think we need to do a IF alignment check again. Last time it was right on, or very, very close. Now with this connected, maybe it's not so close anymore. That's my thinking on that. Okay, let's go after the IF tuning. So I'm staring at this schematic, asking myself, how is it possible that there's no voltage, really, variation on this line? This is what I'm measuring. It's showing the 3/4 of a volt negative and kind of steady. How can it be steady? When you tune in signals, a large variation occurs here. So I thought, well, let's take a look at this circuit here. Maybe there's something wrong on it. There's not much to it. Just a resistor. This resistor reads 2.5 megohms. Here's a capacitor. The capacitor's value is 0.05. I've measured these in circuit using a tester that can test this kind of stuff in circuit. There's no reason to think these guys are out of sorts. So I came over to here and wondered, well, if this ground were lifted, then there'd be a signal path through here. Now these are small capacitors, so it wouldn't be very good for audio. But there would be a signal path here. What if this resistor's open? What if this resistor's open? This was the signal path because this ground was lifted. When I put the ground back on, and kind of snuffed out this signal path, which I don't think this is realistic, but it's just an idea. So what about this resistor? So can I read this resistance? This is hidden inside the can. It's not accessible. This lead comes out, but none of this does. But it comes out the top, comes through the coil here, and comes out here. So if I were to measure the resistance between, let's say, top of this resistor here and top of the volume control, I would read this resistance plus the resistance here. This resistance is probably not very high. I don't really know what it would be. So we should get something like 47,000 ohms or in that range. So let's take a look. Well, of course, I've cleverly already done the test, and here's the results right here. 57 instead of 47. I don't see how, that's up against a 500,000 ohm resistor. I don't think 10,000 ohms is going to make any difference here at all. So this suggests everything is fine with that circuit. So again, the only thing we're left with is very bad alignment. Even that doesn't explain this very well. If you had really bad alignment, it wouldn't be receiving anything. But we have to check. I think that's where I still am. We have to check the alignment and see if by some chance it's a million miles out. Not very likely at all. Okay, I'll get set up to do that. Picked up my coffee cup and realized I hadn't talked about another possibility. Another possibility here is the radio's output was weak, and a smart guy doing all these capacitor changes discovered, maybe through troubleshooting, that there's trouble in that little pi filter. And he discovered or figured out that if you lifted the ground off the pi filter, the output of the radio would go way up. The consequences, RF gets further in the radio where you really don't want it. RF could be working its way back through the AVC and come through again, which you don't really want. But perhaps he discovered that, in fact, that's a better situation for this radio to have that wire disconnected. If you look at where I've connected it here, because I arranged the wire, I went, well, where all could it connect? I connected it right here. There's the green wire right there. The length is perfect to connect to this terminal. This is a ground terminal here, grounded terminal. That's probably where it came from. Now, where did I find it? I found it tucked up under here, like it had been pulled and tucked up under there. The first thing I thought was, well, somebody lost track of this wire while they were working. Somehow it got up in behind and they just lost track of it. And it looks, because they couldn't see the end of it, and it was forgotten about. And I've come along and I found it. And so I'm thinking, well, that was a mistake. So I'm trying to correct the mistake. Maybe it wasn't a mistake. Maybe that was a solution for someone who knows a lot about radios and realized that, again, the consequences are minimal and you get the extra volume. I don't know. Doesn't explain the non-moving AVC voltage. That's still a weird thing. Now for the coffee. Okay, let's give this a go. Just by the way, this is the AVC capacitor, this silver one you see here, and it tested at 0.05, just what it should be. In circuit using this guy. Is it true? I'm assuming it's true. So I have a yellow wire clipped in, and that's going to bring out the AVC, and that's from that special connection right to the tube diodes, and I'm going to connect it to this meter over here. Well, we'll do it with the radio operating, once again, to make sure we're not interfering with the operation of the radio too much. I've picked this meter because the input impedance is crazy high, over 100 megohms, as opposed to the usual 10 megohms. Okay, I think we should start up the radio. Oh, another thing, while the radio's warming up here, I have the signal generator operating, and it's operating, it looks like 459, that's 460. 460 kilohertz, which is the IF. We should hear it come out of the speaker. Once this warms up, or I turn up the volume, one or the other. What's happening here? That's full volume. We hear nothing at all. Try just band. Hey, how come you're totally silent? What's happened here? I can see the tubes are lit. Putting 100 volts onto it. Jim, what did you do? What did you do? I didn't do anything. I didn't do anything, honestly. Just this clip lead. That clip lead can't be doing too much. The volume is still right up full. Well, give it more juice from the here. What happened here? Something has happened here. Something has happened. What could that be? Let's go back to the antenna. Although we should have heard some radio stuff even with it hooked up to the signal generator. Put the volume down so we're not. Antenna in. Oh boy. There's no sound coming out of this thing at all. Jim, what did you do? What did you do to it? Think, man. You've done something. What have you done? That's off. That's on. You can see the light. You can see the light. Yeah. I'm totally silent because there shouldn't be anything going on here like this. Yeah, I've had this operating with these tubes on it. There's just nothing coming from the speaker. This is the kind of thing I don't really like to see. So we do have an ohmmeter hooked up there, but let's switch to, let's use it. Let's use that ohmmeter. Voltmeter. Yeah, I know the wrong words come out of my mouth quite regularly while I'm in here talking. So I'm going to put this onto positive. I'm going to put this range up to 300. And we're going to go and check the B plus and make sure it still has B plus in the radio. B plus, I think, is right here. Didn't I switch this to positive? So there's B plus. That's 250 volts. So the radio has B plus in it. How can it be this quiet? Audio. We don't hear anything. Just listening for sounds. Did I turn it up? Oh. Oh my gosh, what happened here? What happened here? What happened here?
So that is a governance failure or incorrupt. That's what I think the problem is. It's not that these people are pushing something they believe in. That's what we expect.
What? Okay, don't know what happened.
I'm not feeling this right now, and I thought the government was hearing my concerns. But
They're going to turn to where there's no station.
On air.
Just a lot of noise. Okay, we're going to put this back on the signal generator. Right away we should hear a tone. Yeah. Yeah. I don't know what happened there. Probably just confusion on my part. Okay, so now we're hooked up. Now we're no longer hooked up. We're going to hook up to the ABC line. Onto this meter. I don't hear any change. Watch that meter way over there. Okay, I'm going to go on to 3 volts. There's that same 3/4 of a volt, closer to half a volt. I'm going to vary the signal strength coming from the signal generator. Watch the effect on the meter here. The expectation is the meter will go up and down in step with a variation in the strength here. It doesn't go down. You can boot it way up. It goes up. That was way too much signal, but it proves that there is some relationship between this voltmeter and the ABC voltage. So now what I'm going to do, let's see if I can get all this into the camera view here. I am going to adjust the IF tuning, which I did before, and I concluded it was okay. I'm going to do it again. The last time I got a big spark out of here too when I was using a metal screwdriver, and that was a little surprising. It's happened to me quite a few times over the years. Don't know what it means exactly. This can is grounded. Other can is also grounded completely. Sometimes these cans are floating in space. Okay, we're in. You're watching the meter. You can hear it go down. Can there be any doubt about that? You know, I can hear the variation, but I don't really see it on the meter. It's just so strange. This one was just a wee bit out. The meter's almost useless at doing this, for doing this. Oh. Ooh, what happened there? What's happening here? What's going on? Let's keep turning. Going down. Going up with a jump. What's happening here? Just as you're heading in towards the peak, it suddenly, I don't know what it does. I'm guessing something shorting out at that point. And then as if you can't turn this one all the way to the peak. On the way to the peak, something happens. So I'm either squeezing or pushing apart or allowing apart the plates. So what? So what's the point of saying that? Because this is tightening them. This is loosening them. Oh! We're doing better here. What goes on? What can go wrong with these things? Well, that's a good question. What goes wrong with them, and what does this really mean? What's happening here? And I think this might be all part of the picture of the ABC voltage. It could be this radio's tuned very poorly, in fact. I don't know. I'm going to go have coffee. Okay, let's turn this down. So this is the kind of thing that's inside the can here. It'll be sitting like this. Through the holes in the top of the can. 2 holes, you can see 2 screws. It's these 2 screws. And you're tightening or loosening these trimmer capacitors here. Now what could go wrong? So I'm just turning this. I'm just reaching through the hole and turning this. Okay. Yes, that is my stomach growling. Maybe you can hear it. Turning this, at some point, a short seems to occur. You go further, it goes away. Not a short. Something seems to occur at some point. What would be the deal with that? And it seems to definitely affect the output. Is it possible there's a disconnected wire here? Or a cold joint? And as I'm twisting this, no, it wouldn't be at the same place all the time. It's exactly the same spot. So, in between this top metal piece here and the bottom metal piece is a thin sheet of mica. Usually it's mica. Right in there. And that's what's keeping this top piece from touching the bottom piece and forms the capacitor. Now, if there's a short occurring here, you're shorting out this whole transformer would be shorted out. You can still get some conduction just through capacitive connection between the two coils, or who knows. A little bit could still come through. You wouldn't think it'd be very much though. What happened? I turned the radio down, and now I'm turning it up. It's gone again. Where? What? Oh, my stomach is growling like crazy. What's happening here? Okay, we still have this voltage over here. What is happening here? What is going on? Why are you coming and going? Why are you coming and going? So we're feeding in an IF signal. It should come through. Or did the thing I was turning? Which one of these was it? Oh my gosh. Oh no. I think it was this one. Did it just... This is not good. This is not a good situation, Jim. So I'm supposed to have this radio done basically today. It doesn't look like it's going to happen. Does not look like it's going to happen here. Well, let's just do what we did last time. We put the antenna back on it. And at some point the radio came back on. I just have to reach in front of the camera here. We are running the radio with a low voltage, 97 volts, but it's worked fine before. Okay, so we're going to remove this also. What's with you, radio? Why are you doing this? This is very unnerving stuff. Yes. She's gone away. She's gone away. Can't really move these locked tubes. They're right in there pretty firm. What did you do? So the only thing I've done with the radio is I've soldered that wire down. I soldered it, so I can't imagine it's coming and going, and it wouldn't explain the deadening of the radio either. She's gone dead, Jim. Why? Because I'm not turning up the volume. Oh my gosh. What a dork. So someone much earlier mentioned that occasionally I'm turning up the tone thinking it's the volume. Yes, that's what I was doing. Okay. There we are. I am the problem. Not surprising. Okay, back to what we were doing here. We were fiddling with the screw here. Screwing with this screw. Is this the one? Yes. Oh. It's just possible this is an oscillation breaking in. I've got to hook this meter back up. So I have had a number of radios which break into oscillation, and when they do, it doesn't sound like that's what's happening. It sounds like, it makes like a scratchy sound. Okay, with the radio live, going just ahead of the 2.2. A 2.2 mega ohm resistor. So we have the same voltage over here again. Just going to vary. You can't see what's going on. So I'm going to reach across and vary the output of this again. Yeah, I can see the meter move a bit. Okay. Now the question is, does this jump a lot when this acts up here? Well, I wasn't looking. It does jump. Okay, no surprise in that. The reason it gets louder in the speaker is because there's more IF there. More IF to rectify. So there's another spot. Let me vary this again here. So we're getting more. It just seems like the breakdown point in here is also at the max tuning point. So this pop here, that change. So I don't think that's an oscillation. First of all, this is going in the wrong direction. The sound gets quieter. No, it's going in the right direction. Sound gets quieter, it goes down. Let's just tighten the screw right down. Bring it back up. Maybe working the screw will remove the... It's such a specific spot. So, as I was driving the screw down, quite a few revolutions there, this was not changing, sound was not changing, and then all of a sudden it popped into life. This is not the one that sparked, but the spark doesn't mean too much. Now. What's it take? Take this can off. What does it take? It takes two nuts that are very hard to access down in here. Very hard because there's a terminal strip up against it here. The yellow one's just got some wires around it, but even that's a little tough. You take the can off, and then what? And then I'd be looking at this. Well, what could I do then? I mean, what would I see? If the problem is really a wire connection up in here, and this happens, these things can corrode up in here a little bit. You wouldn't expect so, but I've seen it. Then flexing the whole can should give the same sort of behaviors. The can can't flex much. Oh, the can is really in there solid. Oh, went quiet. Is that a good thing? Setting myself up for a shock there. I'm holding onto the can, got my hand on the chassis. So the can is grounded, but something is coming and going. Could it be down in here? Could it be... What are the chances that turning the screw at the top is affecting a wire down here? I would give that like a 1% chance. 1% chance. Cool. So here's my wiring job. This cable and these 3 wires are from me. This green wire is joined to the green wire here under this yellow cover. Something in here was sensitive, so let's start with things I don't think are sensitive. Because you wiggle one thing, you kind of wiggle everything. Oop. In behind. Down below. And this is the connection I just soldered this morning. Don't you find it kind of weird that I'm finding something similar down here to what I was finding with the screwdriver up at the top? I attach this. It says a built-in switch. I can activate the switch by pushing in this. It seemed to work just fine. It's so quiet now. It's a tone control, man. Oh, I've got to stop that. Seems pretty good. Back to this. This guy. It's hard to, you're trying to move just one isolated item at a time, but it's hard because they're all soldered together. So we move one thing, you move a bunch of things. No, I'm not getting any effect. Fixed it. It's all fixed up now. Ooh. This one here seems to be the most sensitive. Could it be this resistor is acting up here? When I was a kid, so I lived in an ordinary house with central heating. And so at night I would listen to the air ducts as they heated up and expanded. I'd hear them tick, tick, tick. And then when they cooled down, they would do it again. And I'd listen to that ticking, and I was kind of impressed at how steady it was. And I got an idea. Well, if that's expansion and contraction, then wouldn't it be the case that what's happening is the furnace, there's a reason why I'm talking about this, by the way. The furnace ducts are shrinking, let's say. The furnace has gone off and they're shrinking, but there's no click, no pop. But they're very close to, the earthquake. They're very close to jumping. I went down to my furnace one day. Actually, I've been to my furnace more than one day, but I was down there and I put my hand on the air plenum and pushed just a bit. I think I was leaning or something. I don't know, pushed just a bit. And way on the other side of my house, I heard a pop in the air duct. And I thought, oh my God, touching the main plenum and almost on the other side of the house, it's releasing a little bit. It's releasing something. Who'd believe that you could push the plenum and way across the house? And so I tried this quite a number of times over the years when an opportunity presented itself, or I noticed the effect quite a few times. The same thing's true in the radio here. So is it impossible that I was screwing literally around with the top and exercising the problem down here? Or is the opposite happening? I'm wiggling this, but somehow it's really transmitting all the way up into the top of the can. It's all very hard to believe. It's hard to believe. Okay, never mind the story. Let's go back to... This seems to be the sensitive area here. How come so quiet now? Take a really close look right in here. There's something going on there. And I'm going to set the focus here on this camera, so just bear with me a moment. As usual, I haven't done it ahead of time. You hear the sound going up and down on its own now. So it's really on the edge. Okay, that's how we want it. Now, don't forget this is switched on here, Jim. Oh, wait a sec. Camera all tangled up. There we go. Okay. So we're looking at this resistor. What I was curious about was the debris that's building up on top of the terminal there, right in the middle of the picture. Sort of in the middle there, in the middle of the picture. I can tell you another story. Okay, I'm going to poke at this now. See, the radio got quiet again? Oh, I'm falling over here. Doesn't seem to do anything. Oh, what? I didn't touch anything. Did I touch this? There's a green wire. I'm rocking the whole chassis here. Sure seems unhappy right in here. Now it's possible there's two things going on, and I've just found both of them. They're not really related. Kind of one of the more likely things is a cold solder joint made by me just before I started this video, right here. This guy. Don't hear the radio doing anything. Got this camera shoved right in there. It's just making me a little nervous. Let's just go back. Let's go back to the other guy. Last thing I was doing was grabbing a ground wire here. Okay, I'm going to grab this wire here. Oops. Grounded it by accident there. Oh. So what's happening here is I'm grabbing a terminal with the pliers. And see my hand? My hand is on the screwdriver, but it's insulated. But that don't matter. That's a capacitor. My hand's a plate, the screwdriver's a plate, and this is the insulation in between. So I'm using a capacitor to inject the noise signals in my body into the radio. So that's what's happening there. That's different. Where'd it go? Just grabbing this? Maybe that's causing a retuning of the IF, what I'm doing. So it looks like this green wire comes out of the IF can and goes straight to that terminal. I don't know what to do here. Resolder all these connections. Get that metal thing out of here. That resistor is bad. Okay, coffee break time. We'll look at that resistor next. Okay, if we look at this resistor, which my attention has been turned to, this guy here, it's using the body end dot coloring system. So we see the body is red. The end, well, see there's a silver end? Well, it's actually the other end. The other end is red. It's the same color as the body, so you don't really see it. So body end, and then the dot is this band here. Red, red. You want to guess that that's brown? That would be 220 ohms. Let's give it a check here. It's in the circuit here, so the power, of course, is off. But the resistor is in the circuit. Well, you'd think if that's a resistor there, that this thing would see the resistance. You wouldn't think it would report a defect. Okay, have we got a defect there? I don't think the radio can operate if that's seriously defective. Like if that's open, I don't think the radio can operate at all. So let's see. So that's a cathode resistor. Its job is to provide a bias between the cathode and the grid. Usually develops 5 or 10 volts or something like that, and we think it's what did I say, 220. Incidentally, on the schematic, the value of the resistor in this position is 220 ohms. So it is adding up. We check the meter and take a reading. So instead of 220, 233. I don't know what that other meter was doing. 233, 220, same thing to me. So, now, could it be varying in resistance? Let's hook this up again. Could it be kind of flex it and it varies in resistance? I suppose that's possible. I suppose that's very possible. Let me put this here. But I think it's going to be a solder joint there that's just not 100%. Hand me another clip lead, please. Thank you. No, there's no one else here. It's just me. And this, we want to go on the other side of that resistor. Now, hoping my connections are good and solid. Is there any variation when I wiggle this resistor here? No, 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 no. So, no trouble with the resistor itself, yet one of those terminals seems to be sensitive. So I'm going to go ahead and resolder all these connections around here. Just heat them up and we'll see if that makes any difference in the end. Okay, let's start it up again and see what happens here. So all I did was run the soldering iron over these connections here. And I'll try to remember which control is the volume control. Sounds quieter if anything. Well, seems pretty stable now. Just can't be the case that this has solved this up here. The weird thing is it has to do with, you know, where the screw is turned, not my pressure or wiggling or anything. We're heading for glory and then that wasn't quite so sudden. I'm turning it very, very slowly now. Let's see. I could spray cleaner in here. I don't know if that's such a good idea because, you know, you got this form that's in there and there's coils and who knows what I'd be spraying. I'd try to spray it through the top here. I'd be mostly spraying it right on the capacitor. The idea there would be there's some dirt. But this isn't dirt. I think this is... So the screw contacts, on this capacitor anyway, the screw head contacts the top piece. And then somehow the screw gets through underneath here. This is all one piece of metal, all around here, up into here. And sandwiched in there is the other piece of metal hooked up to this terminal here. The screw is passing through. How come it doesn't short to the center piece? Because the hole is big enough. If you were to loosen the screw off, this one only goes so far and then it kind of locks up. And get the screw loose, that you can wiggle the screw back and forth. Maybe you could determine something. What are you going to determine? Determine something more than what you've already determined? Okay, so we loosen the screw. We don't want it to fall right out though, because this one I think it'll fall right out. Okay, it's pretty loose. It's really some kind of shorting thing going on, or contact coming and going. It has to be related to the position of the screw and how open or closed this is. Well, how the heck, like, how the heck? Now this is just a model. I mean, this isn't what's in the radio. Something like this is in the radio. Now you can see the sheet of mica here, right there. You see the screw here goes under. So this sort of outer piece is like a U-shaped thing, except they actually change metal. Right in here. This looks like it's press fit. Right here. Really? Is that all that is? That's just pressed in? Come on, there's gotta be more to it. Again, you know, not necessarily is the one that's in the radio like this. But look how they've done this. They've simply pressed this. No, wait a minute. No. Look, this piece up here, man. Come on. This piece comes right through. It's this piece. The terminal here is the same as the spring-loaded stuff. Goes right through there. Yeah. So, but interestingly enough, if this connection were to come and go, this contact here, which you would think would be inconsequential. Well, I don't know, because it's a piece of metal coming up behind it there. Yeah, it's the same as this top piece. The other piece is up this way, comes up this way. If this were connecting into the circuit and out again, because there's some kind of mechanical, a little bit of corrosion in here or something, then you would have this kind of adding in to the capacitance of the overall capacitor, just a bit. That wouldn't make it go quiet, would it? Would it? How could it? It would cause the capacitance to jump somewhere from where it is. You can see how turning the screw would change the pressure here and change the mechanical interaction right here. So that would, one way to deal with this would be to get a grip of this and kind of wiggle it around and try to abrade inside here. But, these aren't supposed to move. This stuff's not supposed to be movable, I would think. I think we can't move this. So the radio's making sound because I've got close to this guy here with my hand. Okay, so these are some interesting kind of insights. So what could be happening is each time this connection comes or goes, the tuning point shoots off the peak point. But if you go to chase the peak point, on the way there you change this connection again. You can never get there. You can never get to the peak point, which is kind of what it's exhibiting. So if it's built like this at all, then that could be the kind of thing that's going on. I got more of these around. I do have more of them around. So I'm going to take a look at another one here. So here's another one. This is totally different. This is not necessarily found at the top of an IF. In fact, you wouldn't find this at the top of an IF, but it's the other extreme. It's very, very simply done. He says, just got two terminals. One going to an upper plate, one going to a lower plate, and between them is a piece of mica. There's also a piece of mica right on top here. Maybe that's to keep this washer from contacting the top plate. Oh, they wrote something on it. What did they write there? Patent something. So this is a real cheap one to make. The frame of it is what's holding everything in place, along with the screw going down the middle. So there's no end around bracket, and the screw itself is nutted on the back here, as you can see. That's curious. And slotted screw here. Not to get too involved with this one. Okay, so what can we do about this thing? Look inside here. I think we can really look inside there. Maybe we can really look close inside there with another camera. Okay, this is a little weird what I'm doing, but you can see the close-up camera aimed at my telephone. Now my telephone might cause some clicky pops here in my shop while I'm doing this. So we're going to look through this camera in a moment. So this is my endoscope here. And you can see what's happening there. Okay, I'm going to look in here using the endoscope. I'm really not too hopeful on seeing too much. The reason is, you know, this is actually meant for cleaning out your ears. The camera's located here, and it's got a scoopy thing sticking out here. So I gotta break the scoop off. I should really buy another one of these and break the scoop part off. And you can see it there. Okay, let's go looking. So now I can only, because of the scoop thing, I can only go in so far. In fact, I could actually turn the screw with it if I wanted. So what can we see in here? What can we see? Oh, okay, we're getting a little bit of a view now. Is there any, what do I hope to see? I have no idea what I'm going to see in here that would help the situation any. Now let me just check focus on my phone here by moving it. Hard to say just what exactly is out of focus there. And it's not exactly a precision camera I'm using. What do we see back there? So if I was to look where I think where I think there might be something worth seeing, we would look this way. And now the other way, I don't know if I can do it because the view is restricted here. Yeah, this isn't going to work there. It's just not. What we're seeing, I can't really identify even what we're seeing here. This is not going to get anywhere, but it's fun to do. I'm coming down this way. Well, it's interesting. Look at the image stay. Oh, I just realized this about my ear thing. The image is staying one way. I'm turning the camera. I'm turning the camera, but the image is remaining the same way. Well, that's pretty interesting. No wonder I can use this on my ear. We're not seeing anything, though. We're not getting anywhere. Not seeing anything. Not getting any. Hey, want to look inside my ear? No. You're not going to do that. No. Well, that was a long shot anyway, but what I was hoping to see was, you know, some of this kind of structure or something that would tell me, oh yeah, it's the screw going through, or the only way forward here on this is either, you know, do the best I can, leave it, or take the can off and look inside. This is the can with the third wire, isn't it? So even that's not terribly easy to do, for crying out loud, because there's a wire. Now, is it a slot or a hole down there? It looks like a hole, not a slot. Yes, so there's the volume control wire goes into the side of this can through a hole. So if we were to loosen the can and pull it up, you'd have this big problem of a wire going through the side. I don't know what to do about that. I don't know what they actually did in there. Okay, I don't know what to do. Don't know what to do. Don't know what to do. Whew. So we had a small problem here on the radio that is interfering with its proper operation. And attempts to repair that could result in some kind of total demise to the radio. You never know. Yeah, I'm going to stop for now. This might even be the end of the video here for today. Uh-oh. Okay, so I'm going to call it quits here for today. The next step, I think the only logical next step, is to take this can off and examine what's going on inside. It could be nothing more than a bad connection. A little bit of solder and we could be right back in business. But who knows? I don't know. So I'm going to stop here and we'll see what happens on the next video. Thanks a lot for watching. See ya.